Module number 6. Computer Software Understanding Definitional Lists. And their purpose. A definitional list is a structured approach for organizing terms and their definitions in a way that promotes clarity and easy reference. This method presents terms, concepts, or phrases alongside brief explanations or descriptions, allowing readers to access and understand complex or unfamiliar information quickly. Definitional lists are commonly used in academic writing, technical documents, glossaries, and instructional materials to clarify subject-specific jargon, new terminology, or concepts that may require precise interpretation. By organizing information in a logical sequence, these lists provide an efficient way to present complex content, aiding comprehension and retention for the reader. Definitional lists also serve as a valuable tool for reinforcing consistency within a document, ensuring that all readers interpret terms similarly and reducing ambiguity and misunderstandings. In contexts such as legal documents, medical records, or educational content, definitional lists help maintain a clear, standardized language that supports accuracy and uniform understanding. They play a crucial role in fields where precision is essential, allowing authors to establish a common vocabulary. Ultimately, definitional lists enhance the clarity of communication by providing concise, focused descriptions, ensuring readers have the foundational knowledge necessary to engage deeply with the content without confusion or misinterpretation. Their structured format thus makes them an indispensable element in both professional and academic settings, streamlining the communication process and fostering a shared understanding among audiences. Enhancing digital information in computer science. Enhancing digital information is a fundamental aspect of computer science to improve data quality, accessibility, and functionality in an increasingly interconnected world. This process involves refining raw data into more meaningful, actionable forms, often utilizing data processing, filtering, and visualization techniques. One prominent area where digital enhancement is applied is data analysis, where raw information is cleansed, organized, and formatted to reveal patterns and insights that drive decision-making. Enhancing digital information is central to artificial intelligence and machine learning, where algorithms transform data into intelligent predictions, personalizing recommendations, and automating complex tasks. Data enhancement methods are employed to protect sensitive information in fields like cybersecurity. Techniques such as encryption, anonymization, and secure hashing ensure that digital data remains protected from unauthorized access and cyber threats. Meanwhile, in user interface design, enhancing digital information involves presenting data clearly and visually appealingly to improve user experience, making complex data more intuitive to understand and interact with. Moreover, enhancing digital information extends to multimedia processing, where compression, resolution scaling, and noise reduction enhance audio, video, and image files. These improvements enable smoother streaming, sharper visuals, and efficient storage use. Altogether, enhancing digital information maximizes data utility, accessibility, and security, which are crucial for leveraging the full potential of computer science in various applications. From business analytics to healthcare, the continuous development of these techniques represents an essential contribution to technological advancement in an increasingly data-driven society. Understanding the Basic Input-Output System (BIOS). The Basic Input-Output System, commonly known as BIOS, is a fundamental component of a computer's architecture. It is firmware that initializes and tests the hardware components of a system when it powers on, ensuring that the machine is ready for operation. Stored on a microchip called the boot read-only memory boot ROM, the BIOS is the first code that runs when a computer is turned on. Its primary role is to load the operating system by locating and launching the bootloader, which then loads the OS into the system's memory, allowing the computer to function. BIOS performs essential diagnostic checks on hardware, such as the CPU, RAM, hard drive, and other peripherals, to verify they function correctly. This process, known as the Power on Self-Test post, ensures that all critical components are in working order before the operating system begins its work. Once the post is complete, BIOS configures hardware settings, and then points the system to the hard drive or other storage device containing the operating system. Though BIOS has been a mainstay of computing for decades, modern systems are gradually replacing it with the Unified Extensible Firmware Interface, UEFI. UEFI offers more advanced features, faster boot times, and enhanced security options. However, the foundational role of BIOS in computer systems remains critical for hardware management and system startup, highlighting its enduring importance in computer operations. Perfect reproduction. The power of binary representation using only 0 seconds and 1 second, or binary code, allows information to be reproduced precisely. Binary representation, fundamental to digital systems, simplifies data to two states, often referred to as on 1 and off 0. This simplicity is the foundation of accurate data reproduction. Each 0 or 1 represents a discrete unit of information, creating a sequence that can encode any data, from text to complex images and sounds. In digital systems, binary signals remain highly resistant to error because they are read as distinct values, eliminating ambiguity. For example, in an analog signal, slight variations may lead to distortions, as these signals are continuous and can suffer interference. Binary data, however, relies on clear thresholds that prevent minor variations from altering the meaning of the data, as values either meet the threshold for 1 or do not, resulting in 0. This robustness enables data to be copied, transmitted, and stored with high fidelity, as systems can distinguish each bit's value without confusion. Additionally, error-checking techniques, such as parity bits or checksums, further safeguard binary data against corruption. With only 0 seconds and 1 second, digital systems deliver consistency, making it possible to access and recreate exact copies of original files regardless of how often they are reproduced. This principle underpins the reliability of digital information and continues to drive advances in computing and data storage. Understanding open-source software. Open-source software refers to software with publicly available source code that users can freely access, modify, and distribute. This approach contrasts with proprietary software, where the source code is typically closed to prevent unauthorized alterations. Open-source software encourages collaboration, allowing developers worldwide to improve functionality, fix bugs, and enhance security. By opening up the source code, projects benefit from diverse insights, innovations, and testing, often resulting in high-quality, reliable software. Examples like the Linux operating system, the Apache web server, and the Mozilla Firefox browser showcase the versatility and robustness of open-source software across different domains. One of the central principles behind open source is that transparency leads to better security. Since anyone can examine the code, potential vulnerabilities will likely be identified and corrected. This transparency fosters trust within the user community, as users can see exactly how the software operates. Additionally, open source promotes freedom and flexibility. Users can use the software as intended initially. They can tailor it to meet their unique needs or preferences. While open source software is often free, its development relies on community contributions and sometimes organizational sponsorships to sustain ongoing improvements. Ultimately, open source software has become vital to the modern digital landscape, driving innovation, promoting inclusivity, and supporting a collaborative ecosystem that benefits individual developers, large organizations, and users worldwide. Spreadsheets. Spreadsheets have become essential tools in personal and professional settings, revolutionizing how we handle data, manage projects, and analyze information. Initially designed for accounting and financial tasks, spreadsheets are now used across diverse fields, including business, education, science, and personal organization. One of the primary advantages of spreadsheets is their ability to organize large amounts of data in a structured, accessible way. Users can easily input, sort, and retrieve information using rows and columns, making spreadsheets adaptable to various needs. The grid-like layout also allows for complex calculations and data manipulation, enabling users to conduct quick mathematical operations ranging from simple addition to complex formulas. In a business environment, spreadsheets are essential for budgeting, forecasting, and financial analysis. Teams can share and update data collaboratively, making real-time adjustments that improve decision-making and productivity. Furthermore, spreadsheet software such as Microsoft Excel or Google Sheets includes data visualization tools like charts and graphs. These features allow users to interpret data more effectively, facilitating an understanding of trends and patterns. In educational settings, students and teachers use spreadsheets to organize study schedules, track academic progress, and perform experiments that require data analysis. Spreadsheets have also entered personal life management, assisting individuals with budgeting, meal planning, and project tracking tasks. Through flexibility and functionality, spreadsheets remain indispensable for organizing, analyzing, and visualizing data across various aspects of modern life. Understanding the basic unit of a spreadsheet, the cell in spreadsheets, the cell is the fundamental unit that enables the organization and manipulation of data. A cell is the intersection of a column and a row, creating a unique space containing various types of information, including numbers, text, or formulas. Each cell has a distinct address, typically identified by its column letter and row number combination, such as a 1 or C3. This designation allows users to efficiently locate and reference cells within the broader spreadsheet. Cells are more than mere placeholders. They form the building blocks for complex calculations, data analysis, and visual representation. Users can perform automated calculations by inputting values or formulas into cells, thus saving time and reducing errors associated with manual computations. Furthermore, referencing other cells enables interconnected formulas and dynamic data manipulation, where changes in one cell can automatically update related data across the spreadsheet. Cells also provide formatting capabilities, allowing users to adjust text alignment, font style, background color, and borders to make the data visually appealing and more accessible to interpret. This functionality is crucial for organizing data, ensuring readability, and presenting information. The simplicity of cells as individual units, combined with their flexibility, creates an environment where users can systematically structure vast amounts of data. Through understanding and effectively utilizing cells, users can unlock the full potential of spreadsheets, making data management, analysis, and presentation accessible and efficient. Understanding the range of cells in a spreadsheet. A spreadsheet is a powerful tool for organizing, analyzing, and presenting data, and understanding the range of cells within it is essential for practical use. A range of cells refers to a group of adjacent cells selected simultaneously, allowing users to work with multiple cells simultaneously. Ranges can vary in size and shape, spanning rows and columns or forming complex, multi-dimensional blocks. This flexibility allows users to manipulate data efficiently, perform calculations, apply formulas, or format data for better readability. For example, a range might include all cells in a particular row, such as a 1 through D1, or it could span several rows and columns, like a 1 to D10. Specifying a range is crucial when using functions or formulas that process data collectively, such as summing values, averaging data points, or finding maximum and minimum values within a dataset. Users can streamline their workflows by applying operations to a defined range, saving time and minimizing errors. Understanding the concept of cell ranges is also essential for creating visual representations of data, such as charts or graphs, which often require specifying ranges to pull relevant information. By mastering how to select and utilize ranges, users can effectively manage large datasets, perform data analysis, and present information clearly, making spreadsheets an indispensable tool for data-driven decision-making in various fields. Understanding the dimensions of usability. Usability is a crucial aspect of design that ensures users can interact with a product or system effectively, efficiently, and satisfactorily. The primary dimensions of usability encompass several interrelated components: effectiveness, efficiency, satisfaction, learnability, and memorability. Effectiveness measures how wholly and accurately users can achieve their intended goals. This dimension focuses on minimizing errors and maximizing the successful completion of tasks, which contributes to the system's overall reliability. Efficiency, closely tied to effectiveness, refers to the speed and ease with which users can accomplish their objectives. When a system is efficient, users can perform tasks quickly with minimal effort, which enhances productivity and reduces frustration. Satisfaction, another critical dimension, reflects users' subjective experiences and feelings while using the system. A highly usable system provides a pleasurable and engaging experience, fostering positive perceptions and encouraging repeated use. Learnability is vital for new users, reflecting how quickly they can understand and navigate the system. An intuitive design reduces the learning curve, enabling users to become proficient without extensive training. Finally, memorability focuses on how easily returning users can recall the interface and functionality after a period of non-use. A memorable system ensures users can seamlessly resume tasks without relearning processes, reinforcing usability. These dimensions of usability collectively determine the quality of interaction between users and technology. Designers who prioritize these aspects can create systems that meet user needs and deliver a seamless, enjoyable experience that fosters user loyalty and satisfaction.